Now we are going to see about paging. So in this video, let's see very detailed about paging. So we just say about paging. Paging is nothing but it's a process where the logical memory of that particular process is being divided into fixed size. So that is what meant as pages. And the physical memory, which is called as the RAM, that is being divided into fixed size blocks, and that you can just say it as frames. So when we for what purpose this paging is being used, in sense, paging is mainly used to avoid the external fragmentation, and also it allows the process to use non-continuous memory, and it also enables the virtual memory, and this also makes the memory management a bit faster, and it makes it very simplifier. So let's just see being used. So here in this diagram, when you just see, you'll be able to see that there is a page table. So this page table is the one where it maintains the mapping between the page number and the frame number. So usually the process has been divided into pages, and then pages have been loaded into the available frames which is in the RAM. So this page table is maintained to map the page number with the frame number. So that when the CPU it generates a logical address, actually it uses the page number as well as the offset. So these are the two things which has been used over there. So that the page number has been used to find the frame from the page table, and the frame number and the offset it gives the physical address. So this is the way it just works. So mainly when you just see about the advantage of this particular paging, so as we already saw, there is no external fragmentation is not being seen over there, and it's very similar, simpler for the allocation of memory, and very easily you can swap between the RAM as well as the disk, and it also supports virtual memory, also just supports. See, for example, suppose if the logical address space, if it is 16 KB, the page size can be 1 KB. So the number of pages you can divide into 16. So if a process it needs 5 KB, so what it will do is it will use 5 pages. So that may be loaded into any 5 free frames in the RAM. So here you can just see how it is being stored over here. So that the logical memory and the logical memory, it has been mapped. This page table is used to map these logical memory as well as the physical memory. So the frames whichever you've seen over here is being mapped to there with the frames, and which is being there in page 0, that is in one, in the frame number 1, and frame number 3 you have the page 2, and frame number 4 you have page 1, and frame number 7 you have the page 3. So like this it is being mapped. So for that the page table helps for it. So you can just see the first, there's a page number 0 is being mapped with the frame number 1, and similarly the page number 1 that has been mapped with the frame number 4, and the page number 2 has been mapped with the frame number 3, and the page number 3 has been mapped with the frame number 7. So like this page table helps you to map the logical memory as well as the memory. So here you can just see how it has been done. So here it has been divided into 4 byte pages, and then it has been mapped. So before you allocate it out, so before the allocation, you just see here. So this is before allocation. And when it has been allocated after allocation, you can just see here how it has been. After allocation, what has been done over here, you can just see here. So this is the way you just do it out. So here you can just see the free frames where 14, 13, 18, 20 as well as 15. So these are the different different pages which is they been there, and that has to be stored, which is in the list. So now when it has been mapped, what happened is the page 0 has been actually uh, page 0 has been mapped actually with the with the 13th 13th one actually. 0 has been mapped with the foot sorry 0 is page 0 is actually 14, and page 1 has been mapped with 13, and page 2 is actually with 18, and page 3 it is actually mapped with the 20. Okay, so that will be the new process page table. So you just see here this one. It is mapped accordingly. And the remaining, when you just see, there is a one more frame. So that is 15. So before allocation it was like this. And after allocating, so those pages have been allocated in the specified frames. And then after allocation, this is what the thing. So this is what the free frame, and in the free frame text only 15 alone has been seen. So this is what actually meant as paging.